Multiplying fractions and mixed numbers. The multiplication of fractions, to multiply two fractions, we write the product of the numerators over the product of the denominators. Then, if possible, we simplify the resulting fraction. Now that seems like a mouthful, but let's figure this out. First, we want to look at what does it mean graphically. So to show multiplication of a fraction, let's shade 1/2 of 1/2. Mathematically, in the language of mathematics, of usually means multiply. So what we're talking about here is 1/2 multiplied by 1/2. But let's think about it graphically. Okay, so 1/2 of this circle here, well, 1/2 would be 1/2 of the circle is this much. That's our first half. This is 1/2 of the circle. Now we want to find 1/2 of the 1/2 we have. Okay, so let's try to shade this. 1/2 of 1/2 is this much, right? This is half of a half. 1/2, and now we want to have the 1/2 of that. So 1/2 of 1/2 is this much. Well, how much is that? Of the whole, this is 1/4. One piece out of the 4. 1/2 of 1/2 equals 1/4. So going back to our words up here, to multiply fractions, we write the product of the numerators, remembering that the numerators are the top number. So 1 multiplied by 1 is 1. We put that here. And then we multiply, or that we put that over the product of the denominators. 2 multiplied by 2 equals 4. That's how we do multiplication. Look at some more examples. And with 5/3 multiplied by 1/4. Again, we multiply our numerators together. 5 multiplied by 1, that's 5. We multiply our denominators together. 3 multiplied by 4 is 12. 5/3 multiplied by 1/4 is 5/12. Now we look to see if can we reduce this. We know 5 is prime, so only if the denominator has a factor of 5 could we reduce this. So we can't reduce this. So this one is done. So we circle or box our answer to show that we are done. All right, let's try another one. 9/10 multiplied by 7/4. All right, first we multiply our numerators together. Here, I could write this out for you too. 9 multiplied by 7 over 10 multiplied by 4. We multiply our numerators together, and we put that over our denominators multiplied together. Ultimately, we want the products here, though. So 9 multiplied by 7 is 63. 10 multiplied by 4 is 40. This is an improper fraction. As long as we don't have any common factors, we can leave it like this. We know the factors of 63 are 3, 3, and 7 are the prime factors, and 40 would be 2, 2, 2, and 5. And so since there aren't any common factors, we're done. This is the solution. We want to leave it as an improper fraction, or we could leave it as a mixed number. 40 goes into 63 once, remainder 23 over 40. And we could leave it either way. The only time it makes a difference is if they're asking you to leave it as an improper fraction, then this would be the solution. If they ask you to leave it as a mixed number, then this would be our solution. Both are correct, though. There's nothing inherently right or more correct about one than the other. Here we have another problem. This one is 16/25 multiplied by 15/32. All right, so we want to multiply our numerators together. 16 multiplied by 15 over 25 multiplied by 32. All right, we can multiply these out to two-digit numbers. 16 multiplied by 15 That's 30. 5 multiplied by 1 plus 3 is 80. We put the placeholder because this is a 10, so I need a placeholder there. And then 1 multiplied by 6 is 6, and 1 multiplied by 1, 160. We add. 8 and 6 is 14. Carry the 1, 240. So this is 240 over, we need 25 multiplied by 32. 5 multiplied by 2 is 10. 2 times 2 is 4, plus 1 is 5. Put a placeholder, the 0, we have 3 times 5 is 15. Again, carry a 1, 6. 3 times 2 is 6, plus 1 is 7. So this would be 800. And we can put this over 800. Now we need to simplify and make sure that we have reduced this to the lowest terms. Because they both have a 0 in the ones place, we know they're both divisible by 10, and we can just eliminate those two zeros. So I have 24 over 80, and we can look at the prime factorization if we want. That's one way to do it, or try to find common factors. Both I can see have a 4. 4 multiplied by 6 is 24, and 4 multiplied by 20 is 80. That reduces my 4s. I'm still not done though. I still have 6 20ths, and I can see that both of those have a factor of 2. 2 multiplied by 3 over 2 multiplied by 10. That's another 1. We're canceling our 1s out, finding common factors in the numerator and the denominator to reduce it. So ultimately, I believe I'm done now, 3/10. So as a reduced fraction, 16 25ths multiplied by 15 32nds is 3/10. Okay, we're getting the idea now, aren't we? So it is possible and often more efficient to reduce before multiplying. To do this, consider the factors in the numerator and the factors in the denominator, and see if we can find any ones to cancel before we get started. Okay, so let's look at this again. 16 multiplied by 15 over 25 multiplied by 32. We know the commutative property of multiplication tells us that we can have this 16 multiplied by 15 over 32 multiplied by 25. We can move them around if we want. We don't even need to do that, but we can if we choose. So let's look at this and see, do we have any common factors at this point? Well, it's easy for me to see 16 times 2 is 32. So I can rewrite this. I'll have the 16, and then also 15. I know there's a 5 in 15, and I know there's a 5 in 25. So I'm going to rewrite 15 as 3 multiplied by 5. Now this is the same thing, as these are just factors. 16 multiplied by 3 multiplied by 5 is the same as 16 multiplied by 15. 32 is 16 multiplied by 2, and 25 is 5 multiplied by 5. So I can see I have a common 16 over 16 and a common 5 over 5. I can reduce those right now. Now I'll multiply to get my product. 3 multiplied by 1 in the numerator just leaves us 3, and 2 multiplied by 5 leaves us with 10. Often this is a more efficient way of solving our problems and finding the solution to a multiplication problem. This is called reducing before you multiply, seeing common factors. I'm going to do the same problem one more time and show you how a shortcut to writing that without having to write out all the factors. But I have 16 over 25 multiplied by 15 over 32. And we're going to say, I see that 16 and 32 have a common factor of 16. Because this is multiply, we know that bar goes all the way across. So I can reduce this, take a 16, 32 divided by 16 is 2. Take out that common factor. Again, I know these two both have a common 5, so I can take 5 out of this one. 25 divided by 5 leaves a factor of 5, and 15 divided by 5 leaves a factor of 3. Now I can multiply my numerators together and get 3, multiply my denominators together and get 10. Again, I think we've shown that the solution to this problem is 3/10. The product is 3/10. But we can just see that once we get good at this, we can find shorter ways of doing it.